Einstein's relativity changed how we see time. We assume it's constant, but he proved it's flexible, stretching or shrinking. Einstein's theory of relativity reveals that motion influences time. The faster you travel, the more time slows down for you. But speed isn't the only factor. Gravity also plays a role. Did you know time moves slower in stronger gravitational fields? On massive planets like Jupiter, where gravity is stronger than on Earth, time ticks slightly slower. Due to extreme gravity of black holes, if you stayed near one for 24 hours, time dilation would make time pass much slower for you compared to people on Earth, and hundreds of years could pass while you experience just one day. Time dilation occurs when time passes at different rates for observers in different conditions, such as varying speeds or gravitational fields. For anyone experiencing time dilation, it's essentially a one-way trip to the future. In 2015, NASA conducted a unique experiment involving identical twins. One twin spent 340 days in space, while the other remained on Earth, serving as a control subject. Due to exposure to microgravity, high orbital speeds, and a weaker gravitational field, time passed slightly slower for the twin in space compared to the one on Earth. Upon returning, atomic clock measurements confirmed a tiny difference in their biological aging, only a few milliseconds less. While this difference was minimal, it provided real-world evidence that time dilation affects humans. In fact, time dilation is happening to you right now. This means that if you had two ultra-precise atomic clocks, one placed on your head and one on your feet, the clock on your head would tick slightly faster. Time moves slightly quicker for people living on top of a skyscraper due to weaker gravity at higher altitudes, causing them to age a bit more rapidly by just a few nanoseconds over long periods than those at ground level. This same principle affects GPS satellites, which orbit Earth at much higher altitudes where gravity is even weaker. Additionally, because these satellites move at high speeds, the combined effects of weaker gravity and motion create a time difference. If these time differences weren't constantly adjusted, GPS systems would become inaccurate by several kilometers each day. If these time differences weren't adjusted, this wouldn't just mean getting lost on a road trip. It would disrupt aviation, military operations, shipping routes, and emergency services, all of which rely on precise positioning. Today, scientists agree that reaching the speed of light is impossible with our current understanding of physics and technology. But what if we could? If we somehow managed to break this universal speed limit, would it be possible to explore beyond our galaxy? As you approach light speed, your mass increases, requiring infinite energy to keep accelerating, something we simply cannot provide. Also, at such extreme speeds, even a tiny grain of sand could destroy the spacecraft. So even at light speed, the universe remains unforgiving. If you enjoyed this video, please like and subscribe. Please also consider commenting and sharing. This will really help to support our channel. Thanks for watching,